Welcome to this presentation. My name is Steve Bartlett, a technical marketing engineer supporting HPE Aruba switching, and this presentation is part of the AOS-CX 10.12 update series and two new features that have been introduced, selective and transparent QinQ, that have been introduced on the CX 8325 and the CX 8400 switch platforms. And this is the agenda. I'll quickly run through an overview of the QinQ feature, followed by some use cases. Then we'll go into some details and configuration and the caveats. And we'll finish off with show and die commands with some details of packet captures as well. For reference, here is a list of acronyms and a glossary of the terms used throughout this presentation. We start with the overview. As part of this overview, a quick refresher of the QinQ technology and where we have been in delivering this feature. QinQ is part of the 802.1ad standard and typically used by network service providers to segregate customer traffic. The service provider and the customer may belong to the same business, and this is typically the segment we are targeting at HPE Aruba, the enterprise market. QinQ adds an additional outer VLAN tag of the customer's tagged or untagged traffic. The outer tag is called the service VLAN tag, known as the SVLAN. So this additional tag provides a mechanism for the service provider to encapsulate and segment the customer's traffic. The traffic received from the customer can be tagged or untagged. The general recommendation, though, is to receive tagged traffic from the customer or tenant. This is to have a uniform source and destination customer network endpoints with an 802.1q tag. A mismatch at either end will break the connectivity model. I'll highlight this in the next slide on a schematic. So the service VLAN tag is used to identify and segregate the customer traffic for different customers or tenants. The customer tag, if present, is preserved. So part of the new feature capability in this 10.12 release is the ability to change the SVLAN outer tag either type from the standard 8888 to 8100, which is the pre-standard version for backward compatibility with pre-standard implementation. This feature, though, is only supported on the 8325 series. And QinQ, it is a layer 2 technology. So here is a simple provider network supporting QinQ. And of course, this doesn't necessarily have to be a service provider. Of course, this can be part of a campus network where the same customer wishes to separate workloads and services and reuse the same VLAN numbering system between sites or campus buildings. So typically on a layer 2 topology connectivity model from one site to another, an 802.1q frame, if this was all layer 2 and trunk or lags, would be preserved intact between each switch to its destination. If we're using QinQ, the 802.1q frame is received by the provider node, and this can be tagged or untagged traffic, but we do recommend tagged from end to end, as I mentioned. And it will provide a QinQ outer tag called the SVLAN, and that frame will then traverse with the inner tag intact all the way from its source to its destination network, where the outer tag, the outer QinQ tag, is removed and the 802.1q frame is then sent to its final destination. So we just have to be mindful of the maximum standard Ethernet frame size at 1518 bytes. We've got the 802.1q overhead, which is 4 bytes, and of course the QinQ tag, which is another additional 4 bytes. And of course, if we were to use jumbo frames, we would have to increase the MTU size even further. Now we come to the overview of base QinQ. Base QinQ was introduced in 10.10 AOS-CX release, and this is where all traffic on a QinQ enabled port entering the CN port, the customer network port, was mapped to a single service VLAN. So this was part of the release supporting the 62, 63, 6400 and the 8360 platforms. So in this example, we've got customer VLANs 10 to 20, all tagged with an 802.1q header. They enter the CN port. They will be mapped to a single SVLAN and then transmitted across the provider network. In this example, the single SVLAN is called SVLAN 100. So the 8325 and the 8400 series support base QinQ, but they also support the additional feature sets. So the first feature set that's in addition on these platforms is Selective QinQ. Now, Selective QinQ provides much more flexibility to choose which CVLANs are mapped to a specific SVLAN. So for an example, we can have 802.1q tag traffic VLANs 10 to 20 mapped to SVLAN 100, for example. Some additional customer VLAN traffic 30 to 40 mapped to another SVLAN of 200. Same with customer VLAN of 7 mapped to, say, SVLAN 300. And all untagged traffic would be a catch-all on the CN port configuration of SVLAN, whatever that SVLAN is configured on that CN port. In this example, it's 300. So all these customer VLANs can be coming down an 802.1q trunk or lag, and with the appropriate configuration, then they can be selected to map to a different SVLAN for those CVLAN 802.1q ranges. So SVLAN 100 for CVLANs 10 to 20, SVLAN 200, 30 to 40, and so on and so forth, and transmitted across the provider network. So the other additional feature on top of base QinQ that the 8325 and the 8400 series support is transparent QinQ. So when basic QinQ is enabled on a CN port, all traffic is double tagged with an outer SVLAN header as it enters that CN port. This isn't very flexible if a standard VLAN 802.1q header is only required. So with the transparent QinQ feature, the CN port can be configured to exclude the outer tag, the SVLAN tag, for a range of standard tagged customer VLANs. And these VLANs are referred to as transparent VLANs. Effectively, they're standard VLANs and they are transmitted onto the provider network with just the original 802.1q tag. So for transparent QinQ, the CN interfaces must be configured as a trunk and the native VLAN must be an SVLAN. More detail will follow in subsequent slides. So if we take an example, we've got two customer VLANs, 30 and 40, wishing to be transparent VLANs, and any untagged traffic on this trunk link will drop into the native VLAN, which is configured as an SVLAN, and it will get the outer SVLAN tag for transmission across the provider network. So if the appropriate configurations are applied to this PN switch, we'll have the customer VLANs 30 and 40 traversing the provider network with just the outer 802.1q tag, no SVLAN outer tag, and any untagged traffic will drop into the SVLAN native VLAN on the CN port. In this case, it is SVLAN 10. And just be aware, on the same port, transparent QinQ is mutually exclusive with selective QinQ. That is only on the same port. Now let's have a look at some use cases. A sample of use cases here. Obviously they are generic use cases, but hopefully they capture the spirit of how the features can be leveraged. So first of all, 10 a day with a set of tagged VLANs mapped to SVLAN 200 and 201 respectively for transmission across the common provider network. Then tenant B with a set of overlapping VLANs, customer VLANs 10 to 30 mapped to different SVLANs across the provider network. And tenant C using transparent VLANs that can mix with the outer SVLAN tags across the provider network. And in the head end, we can leverage VSX as a technology to break out to our various tenants at the head end. Do note this is obviously very important. In all use cases, support is for loop-free topologies only. So do make a note of that. A use case for the VSX on the 8325 and the 8400 series. CVLANs and SVLANs are supported on the ISL PN ports and the PN links, so the mix of standard VLANs and SVLANs are supported on the same interfaces. This applies to the 8325 and the 8400 series only. Now do be mindful, the 6400 and the 8360 series still has base QinQ, and this caveat constraint still applies. The use of VSX with these platforms requires a dedicated PN infrastructure, and there's no support for east-west traffic for CVLANs on the ISL links. PN ports are dedicated for SVLANs only, so do be mindful of this constraint. It still applies to these platforms. So continuing the use case theme with VSX on the 8325 and 8400 series, we could, as an example, have host 1 using transparent QinQ or selective QinQ for VLANs coming into a CN port. On the same VSX pair, we could have host 2 using standard VLANs on a lag or a multi-chassis lag coming into that VSX pair. And on the PN ports, of course, they will support a mix of double tagged SVLANs or standard tagged VLANs as well. So on this example, it could be that the provider network is extended by using another switch that connects the hosts together into the VSX pair. Of course, the CN ports and the PN ports would shift up one to accommodate that topology. So the final use case concerns third-party interoperability, and this concerns the 8325 series only. So the standard QinQ ether type header is 88A8. That's in the outer SVLAN tag. And obviously, where possible, use the standard. But for those pre-standard implementations that are dependent on 8100, the pre-standard ether type, then you can change on the 8325 series the factory default from the standard ether type to the ether type 8100. Do be aware though, of course, it is a global command, which means that your provider network from end to end will be using that ether type 8100. So just be aware of that if you're including a third-party vendor that is dependent on that pre-standard implementation version of the ether type. Details, configuration and caveats. A quick summary of the feature behavior for QinQ. I'm not going to read these out. These are there for your reference. I just leave them up on the video for a couple of seconds before we move on to the next slide. And on to QinQ feature behavior 2. I will read these out. Some feature behavior doesn't change across platforms, so a quick reminder: CN and PN ports will not participate in MSTP, multiple spanning tree protocol. MST PBTUs will be treated as data packets and will be QinQ tunneled, along with LoopProtect usage restrictions. CN and PN ports will not participate in LoopProtect. An SVLAN cannot be a LoopProtect VLAN. LoopProtect packets will be treated as data packets like MSDP BPDUs and will be QinQ tunneled. VSX topologies are supported with PN ports, as we've covered in previous slides. And CVLANs, SVLANs are allowed on ISL links. And VSX ISL links are to use the specific VLANs in the allowed list. Allowed all is not supported. The VSX ISL link will act as a QinQ PN port on both primary and secondary VSX nodes. And ingress and egress ACLs are supported on QinQ ports. And some more details for QinQ feature behavior, slide number 3. So for CN and PN ports configured for SVLANs only, Mac learning is based on the SVLAN tag. And likewise or conversely, CN and PN ports for transparent VLANs, Mac learning is based on the CVLAN tag. Maybe a bit obvious, but I thought I'd put it on the slide. Mirror and S-Flow are supported on QinQ ports, and we'll cover a little bit more detail towards the end on that. Don't forget, increasing standard MTU sizes are required, and this is easy to forget. And QoS marking in the form of the priority code point, the PCP value of incoming CVLAN tag traffic is carried forward automatically to a PN port in the outer SVLAN tag. But of course, if you wanted to change it, fixed values can be set on the interface. And lastly, all transparent VLANs are created as regular VLANs, and CN port and PN ports can support both SVLANs and regular VLANs. And here are the MIB details. Both standard and proprietary MIBs are available. The standard MIB lacks QinQ details, so do use the proprietary MIB, and here is the SNMP walk with the OID value here. And now going into some configuration details, first of all for selective QinQ. So in this example, we have CVLAN, standard VLANs 10 to 20, and they're going to be mapped to the SVLAN 100, and CVLANs 30 to 40 mapped to SVLAN 200, and any untagged traffic is going to be mapped to SVLAN 300 on this CN port. So if we look at the configuration, first of all, it's an access port. That's the first thing we need to note. And the VLAN access is 300, and that is configured as an SVLAN. And for the selective QinQ part, we have this command here, QinQ VLAN map, and then the selected VLAN. So in this first instance, we've got 10 to 20 mapped to SVLAN 100. And then CVLANs 30 to 40 mapped to SVLAN 200. On the PN port, it's business as usual in terms of configuration, but the only thing we've got to be mindful of is the VLAN trank allowed list. Allowed all isn't allowed. You have to specify the VLANs you wish to have traversing that PN port, whether they're single tagged or actually double tagged. So in this example, we've got VLANs, outer VLANs, SVLANs 100, 200, and SVLAN 300 traversing this PN port. And what we'll have then as traversing as a frame, we've got SVLAN 100 carrying the outer tag, carrying CVLANs 10 to 20, SVLAN 200 carrying customer VLANs 30 to 40, and all untagged traffic dropping into SVLAN 300. So some more details regarding configuring selective QinQ on the CN port. The interface is configured as an access port, but the access VLAN must be an SVLAN. Untagged traffic received on the CN port will be mapped to the SVLAN configured on the CN port. That will be the access VLAN. Other tag traffic will be mapped to the appropriate SVLAN as defined in the QinQ map configuration on that interface port. And without a QinQ mapping on that particular CN port, that tag traffic from the customer will be mapped to the SVLAN, which is the SVLAN configured as the VLAN access VLAN. And for reference, we have that sample CN port configuration example here. So let's look at an example for transparent QinQ and the configuration and how it applies to the CN port and PN ports. So here we've got CVLANs 10 and CVLANs 20 to be desired as to be transparent VLANs. And we've also got untagged traffic coming onto the CN port that will be mapped to SVLAN 400. So if we look at the CN configuration on this particular CN port, the first thing to note for transparent QinQ, the CN port does need to be configured as a trunk port, or if it's using a lag, and the native VLAN must be an SVLAN. The transparent VLANs are defined with the QinQ port type network command, and the native VLAN captures all tagged and untagged traffic not specified in this trunk allowed list. On the PN port, this is business as usual. Just specify the VLANs that are desired on the PN port, whether they be SVLANs or standard tagged VLANs. Note that the trunk allowed all command is still not allowed, is not supported. You have to reference the specific VLANs that you desire to be carried across that link. In this example, we've got 10, 20 and 400, and look at 100 and 200 are SVLANs from another port. So the transparent QinQ summary. The CN interface port requires a trunk configuration with the native VLAN configured as an SVLAN, and all untagged traffic received on the CN port will be mapped to the native VLAN, which, as I mentioned, is an SVLAN. The VLAN trunk allowed list requires ranges. The VLAN trunk allowed all command is not supported. If you do configure it by mistake, you will get this error message. And selective QinQ and transparent QinQ are not supported on the same interface. And again, the configuration reference here. So details on how to configure the QinQ ether type on the A325 series. The default is A8A8. Just go into the configuration, enter QinQ ether type question mark, and you'll get the options to change it to 8100. And it is of course a global command. You cannot configure this on an interface. So now the caveats section. The 8325 series is the only platform to support the QinQ ether type header of 8100. Loop-free topologies are the only topologies that are currently supported, so very important to be mindful of that when building out networks using QinQ. MSTP BPDUs are treated as data packets and will be QinQ tunneled. CN and PN ports will not participate in the loop protect feature. Likewise, loop protect packets will also be treated as data packets and tunneled. And note these features that are not supported when QinQ is configured. There is a list here. So the caveats for transparent and selective QinQ. So on the 8325 series, do note the mirror feature behavior. So from egress mirrored traffic from a CN port. Now this could be from a PN to a CN flow or a CN to a CN port flow. Doesn't remove the outer service tag due to the ASIC behavior. So all mirror traffic would have the service VLAN as the outer tag when you're using the mirroring function on the 8325 series on a CN port in this way. For SVIs, they're not supported with SVLAN, so that's the key thing to note. There is a workaround that was actually part of base QinQ as well. So QinQ bridging and routing can be achieved by connecting an external loopback with one end configured as a CN port, the other configured as a standard normal port. There you can configure SVI, but this is not supported on the 8325 series. So CVLANs with SVIs and transparent VLANs are supported as normal, of course. So when it comes to scaling, and this reflects the testing that we've completed to date and does not reflect to any hardware or software limits, just the testing numbers that we've actually managed to complete. We have a recommendation, a general one, no more than 1 to 8 transparent VLANs configured on a particular port. Likewise, for the number of selective VLANs and customer VLANs on a configured port, there are just some testing numbers that we've done today. There are no hardware and soft limits per se. A quick run through of some show and diagnostic commands. So let's look at some show commands. So the first up is show QinQ, and they're the options here. And I'm selected show QinQ detail. I could obviously select a specific interface, but I've decided to show all the detail, QinQ detail on the switch that's been configured. So the first one up is interface 1119. And it's telling me the first part of it is QinQ port type is a customer network and it's a trunk, which tells me it's a transparent QinQ port because it has to be configured for a trunk. And the ether type is 88A8 that it's using. So the transparent VLANs are 10 and 20, and the service VLAN is 400. Now, if you remember from the previous configuration slides, the service VLAN had to be the native VLAN, so that's configured here, the VLAN trunk native. This is the corresponding configuration. And the transparent VLANs are allowed on the trunk allowed list along with the native VLAN. To make it a transparent QinQ port, of course, we use this QinQ port type customer network. So that makes it a transparent QinQ port. So let's have a look at the next interface, which is 1120. So the port type is access, which is an indicator that it's actually supporting SVLANs. No transparent VLANs, as you can see, because they can't mix on the same interface. Transparent and selective VLANs cannot mix on the same interface. So the service VLAN is 300, and that's the access configuration, which is an SVLAN. So that's the VLAN access 300, it's a service VLAN. And here we've got the selective VLANs that are being configured. So we've got customer VLANs 10 to 20, and they're mapped to SVLAN 100. Customer VLAN 30 to 40 mapped to SVLAN 200, and this is obviously the selective configuration mapping here. 10 to 20 customer VLANs SVLAN 100, and likewise for 30 and 40 to SVLAN 200. And the last configuration here is the PN port. It's telling me is a port type provider network, which is a trunk using QinQ ether type of 88A8. And again, it's telling me the number of transparent VLANs that are actually on that port. There's 2, 10 and 20, and the number of service VLANs here are 1, 2, 3, 4, 100, 200, 300, and 400. And there's the mapping. Sorry, there's the mapping here. Trunk allowed 1020 being the transparent VLANs, and these being the SVLANs. So we could just use the show QinQ command, which gives us the ports, the type of port, and the VLAN membership of that port for QinQ. There's also these commands here: show running config QinQ, show tech QinQ, diag dump L2 VLAN basic, and as QinQ is part of the VLAN daemon, you'll get the output for that for QinQ as well. And for debug, there's a separate debugging for QinQ and the various debugging levels here from the debug buffer. So this is a frame capture of QinQ EtherType PN port on the A325 series. So first of all, the QinQ EtherType was 88A8, and you can see the frame here. So it's telling us it's actually a QinQ frame, provider bridge 802.1AD, and the outer tag EtherType is 88A8, which is the standard, and the SVLAN ID is 1000, 802.1AD, 1000. It's decoded that nicely, and here's the SVLAN ID here, 1000, and the inner tag is using the EtherType of 8100, which is for 802.1Q tagging, and the customer VLAN ID is 21, so that would be 802.1Q tagged VLAN 21. Now if we change the EtherType to 8100 on the switch, which I did, and then did the same capture, the decode is slightly different. Now remembering that this is a 8100, the EtherType is pre-standard, which means it actually overlaps with the standard 802.1Q tag. So it's probably more likely than less likely that the analyzer that you'll be using will decode it in the same way. So it thinks it's an 802.1Q tagged header, and this is the decode that the analyzer displayed there. So it didn't indicate it's actually a provider bridge for QinQ 802.1AD. It just flagged it as an 802.1Q tag, but of course it decodes it in a very similar way. So the SVLAN is actually still 1000. That's not going to change, and it will tell you the inner tag of 802.1Q, which is a standard 802.1Q tag for a customer VLAN, and the standard CVLAN tag traffic is 21. So just be aware of that if you're using the EtherType 8100, it's likely that your analyzer will throw out a similar type of frame. So this is a frame capture, QinQ on a CM port on the A325 series. On the ingress, as the frame comes in, you see it's single tagged, and with the EtherType 8100, and the ID of the VLAN is 21 before we go into the IP layer. But on egress, as I mentioned earlier in the slides, it's double tagged still. So it's coming from the PM port to the CM port. In this case, I'm using the EtherType 8100 globally, so you can see that there. And it's still got the double tag on it on egress. So this is going to be the SVLAN ID, and this is going to be the CVLAN ID. So this part doesn't get stripped on egress for the 8325 series. It's the behavior of the Broadcom chipset and where the mirror engine sits at the entry point of the egress pipeline. So this behavior will never change on the 8325 series. It's part of the Trident 3 chipset. The 8400, by the way, is on a different chipset and will give you a single tagged egress frame. Well, that brings us to the end of the presentation. I do thank you for tuning in.